Application of first law of thermodynamics. This law is another form of conservation of energy. And while writing or using mathematically this law, which has three terms, we have to be careful that all the three terms must be having the same unit of energy. Might be calorie, might be joule, might be erg. That depends on your choice. You see, we are going to apply this first law of thermodynamics in different kind of processes. First of all, let's consider isothermal process. Isothermal stands for constant temperature. And internal energy is a state function that basically depends on temperature. If temperature is constant, obviously internal energy too will remain constant. That is to say that du equal to 0, and when du equal to 0, what remains is only heat transfer, that is utilized as work done. If we adopt the process of expansion of gas at constant temperature, it's going to be the example of this type. Second is adiabatic process. Adiabatic stands for no transfer of heat. If there is no transfer of heat, that is dq0, what remains is du, that is equal to minus dw. In adiabatic process, there is no transfer of heat. We adopt that thing by using different approaches, but whenever heat transfer is prohibited or we try to avoid this process, then it will take place, and certain processes or the processes taking place in thermally insulated containers will be of this type. Third is isochoric process. Isochoric stands for constant volume. Constant volume, the work done is given by P delta V. If volume is constant, that means there is no change in volume. That means delta V equal to 0. That way the work done will also be equal to 0. What remains is only two terms dq and du. You could say in brief that whatever the amount of heat is transferred, that is utilized in changing the internal energy. That's isochoric process. You see, when we use the process of heating the gas in a closed rigid container in which the expansion could not take place, rigid simply means that expansion is not possible. That means there would be no change in volume. In that case, this is going to be isochoric process. Isobaric process means pressure remains constant. If the pressure is constant, then heat will be transferred. And when pressure is constant, obviously there is a scope of change in volume. Whenever volume will change, no work will certainly be done. So if work is done, there is term of work, and internal energy is likely to change by the heat transferred. So whatever the heat is given, that is utilized in two parts, in changing the internal energy and in doing the work. Best example could be that of boiling of water or melting of solids. Then cyclic process, cyclic process already elaborated. These processes are represented by some loop or enclosure on PV diagram, and suppose this is circular, then the area enclosed by, see, this is a circle on PV scale, PV graph. This is a closed circle. It's going to represent cyclic process. If you are interested in finding the work, you have to simply calculate the area enclosed by this circle. So that is the way of finding work done in cyclic process.